Exponential functions, they used very extensively in mathematical economics or in any branch of economics whatsoever. So you need to know they have huge applications in economics, and you'll come to know about this in later recordings. Now, first of all, let's come to the point what exactly are these exponential functions. So if b is any number such that b is greater than 0 and b is not equal to 1, then exponential function is a function of the form fx equals to b to the power x. So if you have the function of the form fx equals to b to the power x, okay, where this base is greater than 0 first of all, and this is not equal to 1, then this function fx equals to b to the power x is an exponential function. Let us see why we are not considering 0 and 1. Now in case if you have fx equals to 0 to the power x, this will be 0. This is a constant function. Fx equals to 1 to the power x. In case if base is 1, then anything which is 1 to the power anything. Okay, so for example, 1 to the power 1, 1 to the power 2, 1 to the power n, anything will be equal to 1. So these are constant functions, and you want to avoid constant functions because they do not have the properties of the exponential functions which you want to discuss. So you will avoid this. That is, b's one is that of course b has to be greater than 0 and b not equal to 1. Why you're not even considering b less than 0? Say for example, if you have b less than 0, okay, so oh, this is wrong actually. It should have been, here I've written it wrong. It should be fx equals to b to the power x. You can't write this is only reserved for x. It should be 1 by 2 only. Okay, I'm so sorry. So what I'm trying to say is this, that supposedly if you have the form of the function fx equals to b to the power x, and you want to calculate, say, this f of 1 by 2, that is b to the power 1 by 2. Okay, you can have you can have bases which are lying between 0 to 1. Okay, well, the only problem is, suppose if this is a negative base, suppose if this is like minus 2 to the power 1 by 2, this will become root of minus 2, which is 2 iota, but you want to avoid complex roots. Okay, so what we have understood here is that fx equals to b to the power x form 1. This is the form of the exponential function. This base has to be greater than 0 and it is not and it shouldn't be equal to 1. Okay, now let's draw the graph of this figure. Fine, let me just draw this with different inks. Okay, now suppose if there are two functions, fx equals to 3 to the power x and gx equals to 1 by 3 to the power x. So as you could see here I have explicitly taken b which is greater than 1, and here I've taken b which is lying between 0 to 1. Okay, which is lying between 0 to 1, as you could see here. Is that fine? Now supposedly if x is equal to minus 2, what is the value of fx here? 3 to the power minus 2, which is 1 upon 3 square, which is 1 upon 9. So when x is equal to minus 2, fx is equal to 1 by 9. When x is equal to minus 1, then fx equals to 1 by 3. When x is equal to 0, then it is 3 to the power 0. Okay, anything to the power 0 is 1. Okay, when x is equal to 1, then it is 3 to the power 1, which is 3. And x equals to 2 will be 9.